collections. So what we will be covering in this section or in this session is basic concept about collection, collection interface, and we will be discussing about list, set, and maps. We will be discussing about Iterator, and then we will be seeing few examples also for these collections. Okay, so what is a collection? Collection is nothing but they are designed to handle objects, or rather we can say collection of objects, or in a very simpler word, it is nothing but uh, a group of similar objects. To give a best example, we had discussed arrays in our initial Java basic session. Arrays were nothing but group of similar items which had a fixed length. Similarly, similarly, collections are also a group of similar items, but they are more powerful than the concept of arrays. They have lot many features as compared to arrays. They work like arrays, but as I said, it's more powerful. So it's like, just to give you an example, we can dynamically create an array. So we need not have to define the size before making use of it. We can just initialize it, declare it, initialize it, and as in when we get to store data, we can create its length. So in short, we can dynamically create the size of an array. Where the size is not limited to the predefined value that we set during arrays declaration. Java collection framework is actually collection of interfaces and classes which have ready-made features in them, which help us in storing and processing data in a much better and much efficient way. We would see those usage in our examples that we would see in our today's session. It actually helps you in saving your time to code. So at times, if you want to go ahead and remove certain elements from an array or add certain elements to an array, then it is altogether tedious work to do it in a traditional array. But whereas in collection, it is much more easier to do it. You have well defined methods and functions where you can actually just make use of them, and you go ahead and create your test scripts faster. This is the collection hierarchy. We have two set of hierarchy. One is called as maps and one is called as collection. Now collection have child classes which are nothing but set, list, queue, and in sets we have sorted set, and among them we have other classes called as hash maps. We have trees, we have linked list, we have array list, and all those things are actually part of these uh, collection hierarchy. As I said earlier, it is actually an interface, and each subsequent class implements this interface, and they can have one or more implementations. the beauty of this collection is that you can create your own collection, and you can customize it basis your requirements. So collection, as we know, they are an interface. We can actually create a separate class, we can implement this interface, and we can define our custom methods to suit our purpose. So from complex software engineering projects, from that point of view, when we talk, there is where you can create your own custom methods or custom implementation. But from our Selenium point of view, the standard methods and the standard features what collection provides, we are sufficient enough to go ahead and do our automation testing. It's nothing but stores groups of object. Now, in this, there are various ways to handle duplicates. So at times what happens is, let's say give you an example where we have a table displayed on a web page. Now that table can have as a list of employees of an organization for a given country. Now in a country, I can have different regions and I can have different cities. So the city value for say 100 employees staying in, for an example, Mumbai, the city is same. So we have duplicate records. So if I say Chirag stays in Mumbai and Techcanvass also is in Mumbai, now here if I want to store this result set, city would be a duplicate record for me. But what I can do is I can make use of something called as map, where I can pair these two items and I can have unique values. And I can say Chirag Mumbai and Techcanvass Mumbai. So I can have unique values in such way. But if you see, consider only city for that matter, Mumbai would be a duplicate value. But still it is allowed. Now, a class set, a set interface does not allow this duplicate value. So in this case, we cannot use sets. We will have to make use of maps. And for that matter, we have tree maps, or we have linked list maps, so on. If we need to have certain, if there's a requirement that we need to have unique values, then probably we can make use of the set interface to get about that. So depending upon whatever requirement we have, we can make use of different classes and get our work done. Now list interface allows duplicates and introduces positional indexing. To give you an idea about positional indexing, is nothing but arrays have those indexes. Array elements can be accessed through indexes. That can be achieved in lists, or rather list supports that kind of implementation. Maps having key value pair, it says design does not allow duplicate keys. Now when I say keys are nothing but unique indexes, or other unique identifier for a map. Now in the example that I said, Chirag Mumbai, Techcanvass Mumbai, Chirag and Techcanvass would be the keys, and their values is Mumbai. So the key should be unique, whereas value can be duplicate. And the combination of Chirag Mumbai as a unique value. This is the framework of collections, where you have collection interface, and then you have list, queue, and set interfaces, and array list, vector, linked list, priority queue, hash set, linked hash set, sorted set as an interface, hash set. These are the classes that actually implement these interfaces. So in other words, uh, a method defined in class will have to be implemented in priority queue, as and also a method defined in queue will be implemented in priority queue. And a class which is extending priority queue will have to make use of those methods. Okay. Collections are nothing but they are part of utility package. We have to make use of java.util dot collection, or we can simply put it dot star, so that relevant methods can be called and they can be implemented. But whenever we make use of say any collection related stuff, so for an example array list for that matter, or linked list, or a hash map, we have to import java util. So these libraries, if not imported, compiler will give an error that undefined method or the definition is not defined. We also have a similar class called as java.util.collections that provides various methods and various algorithms like sort, binary search, reverse, max, min, etc., which can be implemented or which can be used as and when required. But what we would be focusing is on the collection uh, framework. Okay, so how do we declare these collections? We declare variables using this way. We have list, we have the greater than less than sign, and then we have something between that, which is nothing but the data type of this collection, and then we have variable name. So the data type over here, the defined data type would tell the compiler that whatever data I'm storing in the variable town will be of type string, or for that matter integer. This is the way we have to declare the variables of a collection. Now look at the declaration where I say map string comma capital. I say capital. It actually says that you have to store variable in the format of string comma string. Now capital will always be string, we consider them as string. So the map capital will have key and a value of data type string. So this is the way we define. Now here in maps, we can also have string and integer, integer and string, or float for that matter, and we can store data accordingly, depending upon the requirement. So a small example over here, let's say you have a list of email IDs. So generic email ID, say info@Techcanvass, say no reply at Techcanvass, say inquiries at Techcanvass. Then you can have another ID, say admissions at Techcanvass. Now these email IDs have different purposes. Inquiries are just for inquiry. Info is to ask for any support related stuff or something like that. Say admissions, email ID may be used for, say, enrolling yourself for a particular program. What we can do is we can store them in a map saying that, okay, I have an ID 1, which is info at Techcanvass. I have an email ID 2, which is at which is inquiries at Techcanvass. Email ID 3, it is at support admissions at Techcanvass, and so on and so forth. So we are giving an indexing to these email IDs. It is nothing but as good as your index page of your book, where you have index number and you have the relevant content on that topic. That is a concept, or rather the overview of maps. There are a couple of basic operations of collection interface, like size is empty, boolean contains, boolean add, boolean remove, iterator. Now size, from the name itself, it says the size of a particular element, be it an array list, or be it a hash map, or be it linked list. This method will return the size of that particular element. Boolean is empty would determine whether that list or whether that collection is empty or not. So it is true or false. If it is empty, it will give false. I'm sorry, if it's not empty, it will give false. If it's empty, then it will be true. Similarly, for an example, we have add object element. It is used to add elements to a particular list or to a particular collection. And remove, for that matter, will remove a particular element from that list. So over here, either we can give the index or we can give values depending upon what collection method we are using. Iterator is a class where we can iterate among the collections. So it's kind of, just to give an analogy over here, the way we use for loop to access each element of an array list, this can be done using iterator. So iterator can be used to iterate the collection class. As I said, and in iterator, we have three methods. One is object next, one is boolean has next, and one is void remove. Next is basically pointing to the next element in the list or in the collection. Has next determines whether there is any value in the next element or not, whether it is true or false. It will always prompt true if there is a value, and it will give false if there is, or rather we can say the list ends. If the list ends, then the next value would be false or null. And remove is where we remove a particular element from that list. This iterator is widely used when we make when we implement array list or we implement linked list to access each element in the list and perform various operations. We will see those in our example once we start getting into different types of classes that we have for collections. Okay, so first one is list. List is an ordered collection, which is nothing but called as sequence. It may contain duplicate elements. Elements can be inserted or accessed by their position in the list. So it is kind of using index based to access an element, and using those indexes we can either insert or access a particular element in a list. We have three types of classes which implements this list. One is ArrayList, one is vectors, and one is LinkedList. This is what we will be discussing about. We will be discussing about ArrayList and LinkedList in the session. Basic operations of list are actually nothing but inherited from basic operations of class, because list implements methods of collection. So these are a couple of few basic operations that also list has. Okay, array list. Array list has no fixed size. It expands as we add more elements. ArrayList class that implements list interface. Now, it allows null as an element, so we can add null in an array list. It allows duplicate, and this is the way we define an array list. Array list string email list is equal to new array list string. So array list and array, so difference between these two is that arrays have fixed length. So if it is full, you cannot add any more element to it. But in array list, you can add new elements. In array, if you want to remove a particular element from array list, what happens? The value is erased, but the memory is still allocated to that array list, to that array. Whereas in array list, if you remove a particular element, we the Java deallocates memory for that element when we remove an element from an array list. Let me give you an example. Okay. Okay, is the code visible?
Yes, it's visible.
Okay, all right. So this is a class where we define an array list and we are adding certain elements to it. What we are also doing is we are removing certain elements from this list, and we are changing the value of a given element in the array list. So how we do it is so starting from the third line, we import java.util.star libraries so that these files are, we can use these files. So if I comment this, I get an error. Compiler says array list cannot be resolved to a type. Compiler does not understand what is an array list. So we have to import those library files to make use of it. Now, how we define an array list is by this way. We say array list string, a variable name obj is equal to new array list string. So what compiler will do is, what it will do, it will create an object of type array list, and it knows that it will store string values. Next, how do we add elements to an array list is using add method. So we say object dot add and we pass the values to it. So we have A, B, C, D, and then what we are doing is we are displaying the values of an array using obj. So if I just print obj, what it will do is it will print all the values of this array list. But if I want to print a particular element, then I have to specify which element I have to, or rather I have to specify the index of that particular element. So let's say elements at index say 1. I say obj dot get index 1. So this will give me the value at index 1. Then what I'm doing is I am saying change the value of 0th index to f and value at index 1 to g. So it will ideally change the value of a, b to f and g. Then I'm saying remove c and d. So it will search the elements c and d and it will remove those elements. So you can remove by giving the values and you can also remove by the index. So if I execute this, all right. So firstly, after this statement, I am getting values at A, B, C, D, and E, the way I have inserted values in this array list. Then what I'm saying is, I want to get the value of the array at index 1. I say obj.get 1 and I'm getting the value as B. Then what I did was I modified the value of 0th and first element to f and g. Okay, I'm sorry, it added value. So it added two more elements in my array list. It says f, g, a, b, c, d. Now I removed c and d. So in this list, my c and d values are removed. So I am just left with f, g, a, b, and e. And then lastly, I say obj.remove 1. So it removed G element. This is array list. Now this to command, what it did was it dynamically created two new elements in this array list. So had it been an array, a normal array, if I wanted to add new elements, I wouldn't have been able to do it because I would have to define the size of an array at the beginning only. But here I can add as many number of times. So I don't have to define anywhere the size of this object, but I can get the size of that object whenever I want it. That's the beauty of ArrayList. Now, where to use this ArrayList from a Selenium point of view? So let's say I have a list of table of let's say employee details. Now employee details may vary depending upon their state. So we can have say current employees and we can have ex-employees. Now the number of current employees may be greater or lesser than ex-employees. We don't know, but there would be different values altogether. And for that matter, all employees. Now, all employees may have current as well as ex-employees. So for this purpose, what we can do is we can make use of ArrayList to capture the values of employees basis the selection. So if I say I want to see only current employees, I can make use of ArrayList to capture current employees. So for the month of say November, if I have current employees as say 30, and in the month of October, my current employees was say 25, 5 new employees were added to my organization, I can make use of ArrayList to introduce more 5 elements into it. And let's say in the month of December, 2 of them quit. I can remove those 2 elements quite easily in my program, making use of ArrayList. So ArrayList is widely used in Selenium automation activities, mainly to store list data, perform sorting operation, accessing certain elements, comparing, and various operations. This is ArrayList.
Hello.
Yeah,
For the last, can you just go back to that this code?
code. Okay.
Yeah.
Yeah.
This object you have added like object dot add a b c d e.
Right.
What would how if we have an Excel file, we have a list of objects. How we are going to identify?
If,
Add.
if we have a list of data that you're saying
Yeah.
stored in an Excel file.
Yes.
Okay. So how we do it now? From Selenium point of view, I'll just give you an overview about it right now, because when we discuss about data-driven framework, that time I have to read a
Okay.
particular value and how to insert
Right.
in the code, that we will see the entire code. But just to give you an
Okay,
overview,
man. No
yeah,
problem.
I'll just give you an overview right now. Is I have say user ID and user name. What I do is
Right.
I store these two in a particular variable and pass it over here. So either I say username, I say username, and I also put say user ID and username, and I go about doing this. Or I can also create an array list of array list. So I can have two array list in this thing. So it can be like, sorry, it could be like I have this array list, and one element is pointing to n number of array lists. So it is 1 referring to 1.1, 1.2, 1.3, and then I have second array list which is pointing to 1.1 and 2.2 for that matter. I can make use of that also. So it depends upon how I have to make use of this data in my test code. So this is that we can read those values from Excel sheet and pass it to our code. Okay. What we can do is we can pass those variable over here directly, and it can read it from the file. All right.
Yeah.
Can we move ahead?
Yeah.
Okay. All right. Okay. So that was array list. This is just another exam of array list. Now there is one more method over here, is list.get class.get name. What this does is it actually gives me the class name of list. The output would be java.util.arraylist. It is basically giving me what class does it, uh, what is the parent class of this variable. Since it is of type list, and that belongs to a class called as ArrayList. This code list.getClass.getName can be used when we try to catch various exceptions. when we have say file IO exception or say arithmetic exception, at times an while capturing arithmetic exception, we might just need to know what class it belongs to. That time we can make use of this piece of code, and we can move ahead and say, okay, this belonged to arithmetic exception. Okay. Adding element, as you said, it is list.add, and then you can keep on adding uh, values to this array list. List.size is where you can get the size of this list, and the value would be 3. It always passes an integer, list.size. Now see, the iterator. How to use an iterator is this way. We say iterator string, we give a variable name, and we say list.iterator. And what it does is, what it will do is, it will keep on executing this loop till we have all values as true. So as next, it will check for the next value. If there is a next value, it will be true. If it is if there is no next value, it will return false, and this loop will be terminated. And to print the next value is, we do it this way, itr.next, and it will print the next value. So for the previous example, it would print Lokesh, Ramesh, and Arthur. We can also do it using for loop, where we say I less than equal to list.size, and we print the values of the list by list.getI. As I showed it in the code, we can directly access using the index. We can do it this way if we are sure which element we need to take it. So we just pass it the variable, and we use get method to get the value of that list at that index. This is the examples. We can skip it for now. Okay. Then moving ahead to linked list. Linked list is similar to ArrayList, but the implementation is different. ArrayList is a normal single, we can say single linked list, whereas linked list is a doubly linked list, where we have the addresses of the next and the previous element stored for the current element. That is linked list, or we can say it as doubly linked list. I hope this concept was discussed when you guys must have done your engineering doubly linked list, where you have addresses of your next and your previous element stored along with the data of your current element. That is doubly linked list. Linked list is faster than array list, where the list of operations are concerned, and linked list is better for manipulating data. This is the way we create a linked list. So we have list string variable name is equal to new linked list string. So we create an object of class called as linked list, the way we did it for array list. In linked list, we can do a forward as well as backward search, and the time that we take to search is actually directly proportional to the size of list. The time taken for ArrayList, linked list, for that matter, hash map, and all these collections are not so concerned for us from Selenium automation point of view, but from a knowledge purpose, we need to understand when to use what type of operations, or rather what type of class we need to use. So just to give you a difference between ArrayList and linked list is uh, ArrayList in ArrayList search operations are pretty fast than linked list. Linked list, since it is doubly linked list, search operation is slower in linked list, whereas in ArrayList it is fast. So if you want to have anything related, any operation related to searching of elements, then we can make use of ArrayList. But if there are operations related to adding or removing certain elements from a list, then we would prefer linked list. Moreover, from memory point of view, array list maintains indexes and element data, whilst linked list maintains element data and two pointers for neighboring nodes, as I said, for the next as well as the previous element. So from linked list point of view, it would require more memory as compared to array list. Hence, it's a bit at a slower end as compared to array list. Let me see if I have an example for this. Linked list example. Yes. Okay. So similar to array list, we define a variable for linked list. This way, we say linked list of string. Instead of string, if we want to have integers, we can put integers also, depending upon what data we have to use. And then we add elements to linked list using add method. If you want to add element in at the first location or an element at the last location, we can do it this way: add first or add last. Now this statement, what it does is it gets the object of the element at zeroth index, and if you want to change the value of the element, we use set, and we say set index, and we change the value of it. So if we execute this code, what I'm getting is, after execution of this command, I am getting value as I1, I5, I3, I4, and I2, the way we added in the list. Then what we did was we added an element first item and last item for the first and the last element in the linked list. After executing this command, I am getting this output: first item, I1, I5, I3, I4, I2, and last element. We changed the value of first element, and it was this. So if I print the values over here, I say, let me print the value over here. After set method. So now you can see the first item was changed first item and rest as it is, because we changed the value of the first element. Then what we did was we removed the first and the last element, and we added a new element in at the place of 0th index. So the value is newly added item I1, I3, I4, I2 after removing second element. So this is the way you can add elements, remove elements, alter the value of elements in a linked list. From performance point of view, what I said, since this code is small, we cannot determine the performance of linked list and array list. But when there are a lot of data, that time we have to see the performance of uh, these lists, and that is where we determine what operation we have to perform, whether we have to only see search operations, then probably we can make use of array list. But if you want to have, if we have more addition or deletion of an element, then we need to use linked list. All right, let's move ahead. This is what I was talking about, single linked list and doubly linked list.